All right, we are going live, and we are live. Hello, everyone. It's a silly thing to say good morning because we have people all over the world. As we get started, actually, I'd like to check in. I'm in Vallejo, California. Where is everybody at today? All right, we're all in kind of different places, so we're all at different times. So yeah, I'm in Vallejo, California. I think we have people connected in other parts of the world. If you're just joining us right now, if you could please share in the chat where you happen to be located. It's always interesting to see where everybody is because it's kind of cool thing about the Data on Kubernetes community. We've got people literally all over the world in lots of different places. And that also means that we have people that are in different time zones. So here it's 9 o'clock in the morning. We'll find out in a bit where our speaker is located and what time it is there. He mentioned that he was probably going to be doing this presentation in his pajamas, which is totally okay. We're cool with that in the Data on Kubernetes community. And speaking of which, it's a very big day for us because it looks like today we will break 1,000 subscribers on YouTube. So if you are not subscribed yet on YouTube, please hit the subscribe button right now. You got it right in front of you. It's very, very easy to do. Hopefully throughout the course of this session, we will get over 1,000 speakers. Also, as usual, you can jump in our Slack. You can check us out on LinkedIn. You can check us out on Twitter. We've got lots of stuff going on. We've got 2 meetups planned next week. We pretty much have 2 meetups planned every week for the next few months, including some weeks with 3 meetups. That being said, if you want to give a talk, if you're interested in sharing some of your knowledge, working with stateful applications, databases on Kubernetes, any element related to the different technologies we're talking about, get in touch with us. We'd be happy to hear from you. You may also have noticed that we have 3 official amazing interns working with us now. We've got Kunal, we've got Vanchika, we've got Karuna, and they're being led by our student program manager, who is Kunal Kushwaha, who's doing an amazing job. So you'll be seeing and hearing more from them as we move forward. Nice to see. We got people connecting from different places. We've got Brazil, we've got Spain, particularly the Basque country in the north of Spain. We got folks in India. Anyway, that being said, we are joined today by Jintao. Very, very nice to have you with us. Where are you and what time is it there?
I'm from China. Here is 0 o'clock.
Okay, all right. And what city are you in? Which city are you in? Are you in Beijing? Where are you?
I'm living in Beijing, China.
Okay, very, very good. A small town. All right, cool. Yeah. Good stuff. That being said, we're here today to learn about Apache APISIX. When did you start working with Apache APISIX?
Last year.
Okay. Very, very good. So you got some experience. That being said, if you want to share your screen, we can start with the presentation now. For all the folks in the audience, leave your questions in the chat and Jintao will answer them at the end of the session. All right. So please feel free to put your questions in the chat. We will be monitoring them and then he will answer them at the end of the session. So Jintao, if you want, you can share your screen and start your presentation.
Yeah.
Perfect.
Okay.
Okay. Good.
Okay.
Yep.
Hello, everyone. This is Jintao Zhang from China. Thank you, everyone. I will share a topic with you how to run Apache APISIX on Kubernetes. First of all, let me introduce myself. I'm Jintao Zhang. I'm active in the Apache APISIX community. Now I'm an Apache APISIX committer. So I'm also got an apache.org email. If you want to contact me, you can send me an email. At the same time, I'm also active in the Kubernetes ingress-nginx project. And now I'm the reviewer of this project. I'm very grateful for the trust of the community. Let's take a look at today's main content. First, let's introduce the API Gateway. Then introduce the main architecture of Apache APISIX. Then comes the demo time. show how to run Apache APISIX in Kubernetes and how to use it as an ingress controller. Finally, it's a summary time. Okay, what's project? What is project proxy? A proxy server, sometimes referred to as a fraud proxy. It's a server that routing traffic between clients and another system, usually external to the network. By doing so, it can regulate the traffic according to present policy and convert and mask client's IP address, enforce security protocols, and block unknown traffics. Systems with shared networks, such as business organization or data centers, often use proxy servers. Proxy servers expose a single interface with which clients interact without having to enforce all the policies and route manage logic with the clients themselves. What is the reverse proxy? Reverse proxy. A reverse proxy is a type of proxy server. Unlike a traditional proxy server, which is used to protect clients, a reverse proxy is used to protect servers. Reverse proxy is a server that accepts a request from the client, forwards the request to another one of many other servers, and returns the results from the server that actually process the request to the clients. And if a proxy server has processed the request itself, the clients only communicate directly with the reserved proxy server, and it doesn't know that some other server actually processed its requests. A traditional fraud proxy server allows multiple clients to route traffic to an external network. For instance, a business may have a proxy that route and filter employee traffic to the public internet. A reverse proxy, on the other hand, route traffic on the behalf of multiple servers. A reserve proxy effectively serves as a gateway between the client's user and the application servers. It handles all the access, policy manager, and traffic routing, and it protects the identity of the server that actually processes the request. Let's take a look at the difference between reserved proxy and load balance. A reserved proxy accepts a request from a client, like this, forwarding it to a server that can fulfill it and returns her server's response to the client. A load balance distribution incoming clients request among a group of servers, in each case returning the response from the selected server to the appropriate client. Okay, let's see what is the API Gateway. An API Gateway provides a unified traffic ingress and egress between clients and backends. One of the main benefits of the API Gateway is the ability to decouple of the complexity of the backend system from the outward-facing API that client using it. API Gateway are particularly popular with microservice architectures, where an application can consist of tens or even hundreds of loosely coupled services that communicate with others over a network. By breaking down a system into microservices, some smaller components based around the business function, development team can deliver changes more quickly and then with monolithic design, where an API proxy simply route requests and response. An API Gateway offers additional functionality around the manager incoming and outgoing traffic. A gateway can also handle several discovery and load balancing of the request crossing multiple backend instances. In the case of monthly API, where clients paid based the number and the frequency of requests, a gateway can manage the rate limits for different clients. An API gateway can facilitate the processing of releasing new functionality to producing with canary release. The API gateway routes the specifically propagation of the incoming requests to a new version of the server, enabling the team responsible to monitor for issues where the limiting the impact of any failures. Once the team is confident, traffic is switched over the new version. Configuration of the gateway is typically managed through policies applied by command line interface or admin API, while some gateway also offer an managed GUI like Apache APISIX, and it can manage traffic topologies. Now, why we need API gateway? Decouple your system's public-facing API endpoints from the microservice architecture underneath allow you to make change to the microservice without impacting the consumer of the public API. This consistent for consumer is not just important for existing microservice-based system, but also for the organization moving from a mostly architecture to microservice architecture. In the late case, in implementing an API gateway at the start of the migrating process, provide consistent interface for clients to using API where the architecture is broken down and rebuilt behind it as a single point of entry to your system. API Gateway restrict access to your microservice from the outside of the world, reducing the partition attack surface compact to an directly client to microservice design. An API gateway can be used to manage IP allowed list and denied list, and implement authentication and authorization. Also, not only does this ensure that only valid requests are allowed through, but it is also more effective that implement the logic in each microservice, which may mean replicating it for multiple languages and frameworks. One of the many advances of microservice architecture is the ability to scale service independently according to the load. And API Gateway can provide the load balance to ensure even a weighted distribution of incoming requests across the available instance of the service. Where the high available is required, load balancing can be combined with rate limiting and through to protect the system from unexpected speaking in traffic, including denied of service attack. In implementing this feature, and the API Gateway provides a center platform for manage this functionally. Again, this is avoid to duplicate effort that would be involved in applying the functionality to microservice in multiple languages. Let's say API Gateway co-functions. For example, dynamic API management is required, and it should have some function like load balance, authentication, authorization, and traffic management and observability, like monitor, logging, and tracing, and some analyzing. For example, if the API has some cost, it should can be used to analyze it. Okay, let's say CNCF for API Gateway Landscape. There has some different choice of API Gateway. These API Gateways projects using different technology stacks and different level of activity, and it have different performance. Okay, let's talk about what is Apache APISIX. You know, APISIX is not a word. This is a word we created because 6 means lucky in China. We hope APISIX can bring lucky to others as well. Apache APISIX is Apache Software Foundation top-level project. It's a cloud-native API gateway, and it has so high performance, and it's fully dynamic. We can change any configuration through admin API or using dashboard to change it, and it's hot reload. It's Apache APISIX is most active open source API Gateway project. You can see this screenshot. It's monthly active contributors. You can see Apache APISIX is #1. Okay, let's see the Apache APISIX architecture overview. It's based on NGX plus Lua. NGX provides high performance and robots. Using it, we can easy to add some advanced functions, and etcd as the storage. Etcd is a cloud native storage, KV storage. We are cloud native architecture. Okay, let's see Apache APISIX functions. It can support many protocols like HTTP, HTTPS, HTTP2, gRPC, TCP, UDP, QUIC, MQTT, and it can run on multiple arches like Kubernetes, DoK, AWS, Google Cloud, and ARM or any other Linux distributions. And it includes some functions like monitor, security, cache, logging, routing, and it's easy to custom plugins, so you can easily to custom some functions you need, and it can connect to many applications like Prometheus, OpenID, Grafana, Vault, Kafka, and Skywalking, Apache Skywalking. And it can using not only etcd and console and Knuckles for discovery, so for service discovery. Okay, let's talk about how to run Apache APISIX. You can run it using binary or using doc image, and or you can using Helm chart to deploy it on Kubernetes. Let's coming to demo time. Okay, let's deploy httpbin demo. You can just run kubectl create as demo and run httpbin image to and export it. We can using kubectl get port and service to see if it is running, and export to using httpbin service. And we can deploy Apache APISIX. We can just using APISIX Helm chart repo, just git clone it and cd kubectl create another namespace, and you can just run helm install APISIX charts APISIX and set gateway.tab to node port and specify the namespace APISIX. Okay, after this finish, you can just run kubectl slash APISIX and just using curl to put a new router to Apache APISIX. You can just run it. Now we add the new route using http.org as its host name, and the backend using httpbin.daemon. Okay, let's visit the daemon using APISIX. We can just using curl to visit the APISIX admin API to double check if the route has been created, and just using curl to curl to visit it, and with the host http.org to visit it. Okay, we can find a way. We can visit the httpbin service correctly. Okay, let's see how to run APISIX as an ingress controller. We can just clone the APISIX Helm chart repo, and we can just using Helm install it and set ingress controller enable to true, and it can deploy APISIX gateway and etcd and APISIX ingress controller, and we can just export node port and node IP. We can just curl it. We can find. We can got 40 fail will not find the error because we don't add any router to it. And we can create an APISIX router CRD. It's way using CRD to extend the Kubernetes to implement the APISIX ingress controller. You can just add ingress APISIX router CRD like this. You can just set the host with host using ingress.httpbin.org and pass that to /get. Okay, we can kubectl apply it and wait for a moment to sync the APISIX router to APISIX gateway. Okay, let's export the node port and node IP, and we can query it using with host ingress.httpbin.org, and we can visit it correctly. Okay, let's see all the CRD is our using to implement APISIX controller. We add some CRD like APISIX cluster configure, APISIX cluster consumer, APISIX router, APISIX TLS, and APISIX upstreams. Okay, this is the APISIX ingress controllers architecture. Now we split it to control plano and data plano. Data plano is fully APISIX gateway, and we can just using APISIX ingress controller to as a controller manager. It could watch the Kubernetes API servers. This architecture is high availability and more flexibility. You can deploy APISIX outside of the Kubernetes. Also, you can deploy it in Kubernetes cluster. Okay, let's say there has many choice of proxy or API gateway, like NGX, COM, and traffic invoice, and Istio, or Spring Cloud gateway. But if we using Apache APISIX, we can make it easy. We can using Apache APISIX as SLB and API Gateway and APISIX and APISIX ingress, and also include APISIX mesh. It can work with Istio or Kuma, and we can using APISIX Java or Golang plugin to work with Spring Cloud or Spring Boot. The benefits is we can just easy to maintain, and it's operates friendly, and it can for dynamicity, and it can highly scalable. Yeah. Okay, it's summary time. Today we talk about what is API Gateway and why we need it, and what is Apache APISIX, and how to run APISIX on Kubernetes, and using Apache APISIX ingress controller. Here is Apache APISIX Git repo, and you can connect me through Twitter. Thanks all. It's all.
Got a lot of information in there. First question, all right. First question. I'll put this here in the chat too, so you can have it. I know we just spent a good amount of time getting a very in-depth look at Apache APISIX. One of the first things that someone asked me is, and when I was researching before this meetup, is that there is also API 7. Have you worked with API 7 and maybe if there are any advantages or disadvantages?
API 7 is API 7 and APISIX has the same data plane. So its core is the same. API 7 has changed the control plane using just change the dashboard to add some functions like multiple user, multiple workspace, and some permissions. Yeah.
Okay. Good. We got another question. So when you started working with Apache APISIX, what was the most challenging part of it? All right. When you got started, what was something that, you know, for beginners or people that are trying it, what are some of the difficulties or challenges that you had when you started using Apache APISIX?
Apache APISIX, I just saw it using NGX, it based on NGX plus Lua. Lua language is too small and used not frequently. So we need to I need to learn how to using Lua to plug into to extend the APISIX and to how to write the plugin.
Okay, very, very good. Next question. This one's from Vlad in our audience. I'll send it over here. So why should I choose APISIX over ingress-nginx? Nginx, sorry.
Oh, yeah, let's see this.
Good.
Apache APISIX ingress, we split it to control plane and data plane. We can deploy Apache APISIX outside of Kubernetes. So its APISIX ingress controller is independent with APISIX data plane. So we can keep the traffic health. We can keep the traffic healthy when APISIX ingress controller pod is be killed.
Okay, good.
Okay.
Next question, also from Vlad. So let's get this in here. So ingress-nginx does not support gRPC on non-SSL port without customizing the config template. How good is support of gRPC in APISIX? Wow, lots of letters coming together there. Let's unpack that a little bit. So ingress-nginx does not support gRPC on non-SSL ports without customizing the config template. So how good is the support of gRPC in APISIX?
It's full support gRPC and double and TCP, UDP, and Quick and some other protocols. Yeah, it's fully supported.
Okay, so fully supported. That's good to know. Let's take a look. We got a comment. Oh, this is just a funny comment. What project would you like to work on more, and why is it ingress-nginx? That's from Ricardo. Very, very good. All right. I guess, like I said, in terms of, getting started, you mentioned we got a question from Tim. So what is something we should take into consideration when switching from, for example, ingress-nginx to APISIX? All right, so I'll write that one in here too. So what is something we should take into consideration when switching from, for example, ingress-nginx to APISIX?
If there has some functions where ingress-nginx don't support it, you can try to using APISIX ingress controller. But normally we using ingress-nginx. Ingress-nginx is the most usually ingress controller implementation.
Okay, implementation, yes.
And it's so popular, and it based on nginx. But if we need to change some configuration, nginx need reload. But APISIX is for dynamic. We can change every configuration's hot reload.
Okay, good stuff. All right, very, very good. If we have other questions, feel free to put them in the chat. Jintao will also be available in our Slack. If you have other questions that you would like to ask, you can reach out directly there. Very informative session. Great, great slides, great explanations. I think we got a very good idea now about what Apache APISIX is all about. Jintao, if I could ask you to stop sharing your screen, because we're getting to the last part where we have something to share with you on our end.
Yeah.
Perfect. Good. So while you were talking, our artist, Angel, was very, very busy. Can you see my screen?
Yeah.
While we were talking, our artist, Angel, was creating this piece of art to represent. Obviously, there was a lot of stuff covered there, but I think he did a good job of getting some of the key concepts that were in there, fully dynamic, high performance, all the different things that were there, and this nice artistic depiction. He was doing that while you were talking. So that's always a nice thing to see. As you mentioned, you're accessible on Twitter, easy to find. Perhaps we can share those slides later as well. I think it was a very, very good presentation, and I hope we can have you back. And speaking of having people come back, we will be doing a co-located event in KubeCon. Details about that will be available soon. And perhaps we can have Jintao as a speaker with us again. I think our audience enjoyed it very much. We had some good questions, good interactions there. Yep, still getting good feedback. So Jintao, thank you very much. We will let you go to bed now so you can sleep and rest for tomorrow. But once again, thank you very much for joining us.
Yeah, thank you.
And we did break. We have more than 1,000 subscribers on YouTube. So thank you to all of you for subscribing. This video, if you arrived a little bit late, will be up on our YouTube channel today. So you can go back and refresh. We're still getting good feedback in the chat. Thank you everyone for your comments. And we will see you all next week for our meetups then. All right. Take care. Have a good one. Bye-bye.